7. Engineered systems are built into every A320 family aircraft you board. Most passengers never notice a single one. This countdown moves from details you can verify yourself on your next flight to flight deck architecture that fundamentally separates this airplane from everything Boeing builds. We start at number 7 with a small device hidden behind a ceiling grill in the lavatory. Number 7. Every lavatory on the Airbus A320 family, from the A320 up to the A321XLR, contains a smoke detector mounted just above the mirror, hidden behind a small ceiling grill. This detector, part number 215000102, is required by Federal Aviation Regulations 25.854 and by Certification Specification 25.854. Its signal runs through the Cabin Integrated Detection System, called CIDS, directly to the fire warning computer. If smoke is detected, the system triggers an orange smoke lamp in the lavatory mirror frame. Passengers can spot this lamp illuminated during a real event or during a crew test. The CIDS also commands an automatic discharge of the built-in waste bin fire extinguisher if temperatures rise above 85 degrees Celsius. The cockpit receives an immediate ECAM message saying "Smoke in LAV," and the maintenance log records a fault code for inspection at the next check. Tampering with this detector is a serious offense, carrying Federal Aviation Administration penalties up to $4,000 per violation. This safeguard is present on every A320 family aircraft, whether you are flying short-haul or across continents. Airbus A320's fly-by-wire envelope protection, called Normal Law, is a silent software guardian shaping every control input. Instead of direct mechanical links, the Sidestick sends requests to computers, which enforce strict boundaries on pitch, bank, angle of attack, and speed. The system's most critical shield is Alpha Pro T. As angle of attack nears 15 degrees, the computers override the pilot, commanding nose-down pitch to prevent a stall. Even if the Sidestick is held fully back, the aircraft resists further pitch-up, and the flight displays confirm the intervention. Bank angle is tightly managed. Up to 33 degrees, releasing the Sidestick returns the wings to level, a neutral return feature. Push further, and the system allows up to 67 degrees of bank, but never more. That hard 67-degree cap is absolute, regardless of pilot input. Overspeed protection activates if airspeed exceeds VMO by 6 knots or MMO by 0.015. Mach, pitching the nose up and limiting roll to 40 degrees. These protections meet CS 25.203 requirements, keeping the aircraft within safe aerodynamic limits. For passengers, these protections are invisible until felt, a brief jolt if a boundary is hit, or a subtle attitude shift in turbulence. Every activation or law reversion is logged for maintenance, ensuring the system's silent authority remains traceable. The A320 cockpit is missing something most pilots expect: a central control column. Instead, each pilot has a Sidestick mounted outboard on the side console, the left for the captain and the right for the first officer. The Sidestick is the primary flight control interface, sending electronic signals to the flight control computers. There are no mechanical rods or cables. Every input is interpreted by software, then routed to the control surfaces. The design fulfills FAR 25.777 redundancy requirements by giving each pilot an independent control path. If both Sidesticks are moved at once, the system detects a conflict. The ECAM displays dual input, and both sticks remain active, blending their commands. To resolve a disagreement, either pilot can press the priority button on their Sidestick. That silences the other input and triggers an amber priority left or priority right alert on the ECAM. The absence of a yoke frees up the center console, allowing for a fold-out tray table and clear access to the ECAM displays. For maintenance, the flight control computers continuously log Sidestick force sensor data, flagging any bias or fault as stick fault for inspection. There is no control column, and that is the first thing that makes this airplane different. Number 4. Only the A321LR and A321XLR carry a pressurized crew rest compartment hidden in plain sight at the rear of the cabin. On these long-range variants, a small lockable door just behind rows 30 to 33 marks the entrance. The placard reads "Crew Rest," and a green C indicator confirms the compartment is sealed and pressurized. This module is not found on any other A320 family aircraft. Its inclusion is driven by FAR 25.853 and CS 25.853, which require a dedicated, fire-protected, independently ventilated rest area for flights exceeding 8 hours. Inside, the compartment is isolated from the main cabin by a double-seal bulkhead and monitored by its own smoke detector and temperature probe. Any loss of pressure or fire event triggers an immediate ECAM message, crew rest compartment depressurized, and isolates the fire extinguishing system from the main cabin. Airlines operating true transatlantic or ultra-long domestic sectors like JetBlue and Iberia specify this module in their A321LR XLR fleets. For passengers, the only clue is that discrete door. Most walk past it without a second glance, unaware that it marks the boundary between the passenger cabin and a hidden pressurized sanctuary for the crew. Maintenance teams check the pressure seal every 2,000 cycles. Any drop in integrity is flagged for immediate inspection. This feature is a direct response to fatigue management rules, and it is visible only on the 2 longest-legged Airbus single aisles. Number 3. The Overwing emergency exit hatch on the Airbus A320 family is a Type 2 plug-type door, designed for direct passenger operation. Sitting above rows 15 to 18, this hatch weighs approximately 33 pounds, about 15 kilograms, and is fitted with a spring assist mechanism to reduce the required lifting force to under 30 newtons. In an evacuation, the sequence is clear. Lift the recessed handle, rotate the hatch outward onto the wing, and stow it either on the adjacent seat or throw it clear if speed is critical. The slide or slide raft packed just beneath the hatch deploys automatically once the opening is clear, inflating in 2 to 3 seconds to create a 45-degree escape path over the wing. Certification under FAR 2, 5.809 and EASACS 25.809 requires that 90% of passengers must be able to evacuate within 90 seconds using these exits. During recent drills, average evacuation times were recorded at 84 seconds. The latch and slide mechanisms are inspected every 500 flight cycles, with any wear or fault triggering a mandatory check. The Overwing exit is the only passenger-operated emergency egress on the A320, and its operation is included in every exit row safety briefing, a detail that matters when seconds count. Number 2. The A320 family maintains a cabin altitude target of approximately 6,000 to 8,000 feet, a value set by the environmental control system and enforced by the pressurization control computer. This system is governed by FAR 25.831, which limits cabin altitude to 8,000 feet at all times. During cruise, most flights hold the cabin near 6,000 feet, with the outflow valve positioned by the CPC module to follow a programmed schedule. Passengers will notice a gentle pressure change, an ear pop, about 10 minutes after takeoff and again just before landing. That sensation is the outflow valve, not the pilot, modulating the pressure gradient at a rate of no more than 300 feet per minute. This is slower than the regulatory maximum and is designed to reduce discomfort. On the NEO variants, a digital actuator refines the valve movement, lowering bleed air extraction and saving about 0.4% of fuel per block hour. Some airlines display a cabin altitude readout on the seatback screen, confirming the system's set point. If a press valve fault appears, maintenance inspects the actuator and logs the event for corrective action. The system's behavior is invisible unless you know to link the timing of ear pressure changes to the logic of the outflow valve. Every passenger experiences it, but almost no one realizes the sequence is automated, regulated, and quietly optimized for comfort and efficiency. Every safeguard, every alert, every silent check on the Airbus A320 family converges in one place. ECAM, the Electronic Centralized Aircraft Monitoring System. ECAM isn't just a display. It's a dual-screen nerve center, quietly watching every system from hydraulics to cabin smoke detectors. When a fault appears, ECAM's logic springs into action. The system instantly selects the relevant page, engine, hydraulics, smoke, or pressurization without waiting for the crew to search. Alerts are color-coded for urgency. Red signals immediate danger, amber means caution, blue details procedures, and green confirms normal status. The architecture is built around FAR 25.1329, demanding clear, centralized fault indication. On the A320, a failure like engine 1 fire triggers a red flash on the upper ECAM screen, while the lower screen lays out a step-by-step checklist. Each action is confirmed with a press of the ECAM clear button. Meanwhile, the cabin display flashes a red icon above the aisle, signaling the cabin crew. If the issue involves the cabin, like lavatory smoke or a pressurization drift, ECAM automatically sends a fault code through ACARS to maintenance, logging the event for inspection at the next stop. ECAM's design compresses the time between detection and action. Airbus Human Factors research found that ECAM cuts crew reaction time by 30% compared to paper checklists. In a real emergency, this speed can mean the difference between a contained event and a crisis. For passengers, the only sign might be a brief red flash or a muffled cockpit announcement. For the crew, ECAM is the silent partner, tracking every anomaly, prioritizing threats, and recording each event for later review. Across the A320 family, ECAM transforms every warning, whether it's lavatory smoke, pressurization, or sidestick conflict, into a fully traced, prioritized, and logged sequence. It is the unseen system that connects cockpit, cabin, and maintenance, quietly defining the Airbus approach to safety and workload. Across all 7 systems, one pattern stands out. Intentional engineering choices like sidestick control, ECAM logic, or automatic waste bin extinguishers shape every A320 flight, often without a passenger noticing. These features exist not for novelty, but to meet certification, operational efficiency, and safety. That is the Airbus philosophy.